If you're a beginner, then Section 2 is going to be very important to you because this is where we're going to provide the big picture, and everything from this point will build on this. So one thing to notice down here is that you have client-side computers, and up here you have server-side computers, and in between you have network devices. So the communication that goes between the clients and the servers and back all go through these network devices. Now the course will not focus on network devices, but it will focus heavily on the client side and server side of things. We will touch though on some of the information that you'll want to know about your computer as far as how it does communicate with the network. So there's a MAC address, there's an IP address. These are things that are assigned to your computer to help it communicate. In addition, we're going to talk about the operating systems on the client side and server side computers, and as you'll see that Windows and Linux are the primary operating systems for these computers. And so with that, we'll go ahead and get started with Section 2. Now that you know about the different types of computers, it's time to talk about how those computers communicate with one another. And in order to form a network connection, each computer must have a network interface card, or NIC for short. Sometimes an interface card is also referred to as a network adapter. Now these interface cards can either be physical or wireless. So if you have a wire coming out of the wall that you connect directly to your computer, that would be a physical connection, and typically the wire is a Cat5 or Cat6. Alternatively, you could have a wireless connection, and you've probably heard the term Wi-Fi, and so in that case your laptop communicates wirelessly with a remote access point, and then you connect to the network that way. But again, in either case, you have to have a NIC in order to communicate on a network. In addition, a NIC is going to have a couple of identifiers associated with it. The first is called a Media Access Control Address, or a MAC address, and the second is called an Internet Protocol Address, or an IP address, and those terms will be discussed in a little more detail next. The Media Access Control Address is a hard-coded, unique value that does not change over time. It's assigned when it's manufactured. The MAC address is sometimes called the physical address or the hardware address, and it's used for communication on a local network, such as your home network. Don't worry too much about this for right now. What's important to know at this point is that each computer has a NIC, and each NIC has a unique MAC address. The Internet Protocol Address, or the IP address, is a unique identifier within a network. Now again, so if you join a different network, you may receive a different IP address. So the IP address does change, and it is relative to the network that it's joined to or connected to. For right now, just remember that each computer needs a network interface card, and each network interface card receives a unique IP address when it is connected to a specific network. Often, computers are referred to by their IP address, but that is just as a convenience when you're searching within a network to find a specific machine. You'll typically look or ping or locate a computer by its IP address. And we will be looking at this in more detail later on in the course as we either search for a computer or as we look for information about our own computer. Now, if these computer terms are not making a lot of sense, let's try to draw an analogy between these terms and sports. So the network interface card, or the NIC, is like you as a person. The MAC address is like your name. Your name doesn't change no matter what team you play for. The network is like a team, so you want to go and join a team. When you join the team, you receive a jersey number. So the IP address is like your jersey number. It's unique to you on that team, but if you change teams, you would receive a different jersey number. So hopefully this analogy will help you understand these terms in relation to something you might be more familiar with. There's a concept we need to discuss before moving on, and that is the concept between an IPv4 IP address and an IPv6 IP address. An IPv4 address looks similar to this. It would have the potential of 3 numbers and 4 sets of numbers. Now, the number of combinations that are possible is not sufficient to accommodate all of the computers and devices in the world going forward, and so they've come up with a new format, which is IPv6. Now, this course is going to discuss IPv4 because it's still very relevant today, and going forward it will be, but eventually IPv6 will take over, and the difference is really just the number of combinations of IP addresses that can be assigned, and obviously there's a lot more combinations that can be assigned with the IPv6. But again, this course will focus on IPv4. Another concept to be aware of is the term called a subnet mask. Now, subnet mask is beyond the scope of this course, but it's important to be aware of it. So what a subnet mask is it's part of the IP address. An IP address is made up of 2 components, really. The first part is the subnet mask, and that can vary in length. So you have an IP address that is 12 digits long. Part of those 12 digits, the first part, would be the subnet mask, and it can vary in length again. Now, the reason that's done is so that you can have either many networks with a small number of computers on each network, or a few networks with a large number of computers on each network. So out of the 12 digits that you have for an IP address, if there's say 3 digits that make up the subnet mask, then you would be able to have a lot more identifiers available to assign to computers and devices within that network. If the subnet mask is long, say 9 digits long, then you have essentially 3 digits left over for assigning identifiers to computers within that network. So again, it's just a concept to be aware of. It's beyond the scope of this course, but it is important to know that part of the IP address identifies the network, and the remainder of the IP address identifies or provides the ability to assign identifiers to computers or devices within that network. At this point, I think it's a good idea to take a step back and have a high-level view of the history of some of the major events that have evolved, and that will hopefully give you an appreciation for why some of this old stuff matters, and that you'll see that some of the old stuff was actually the foundation of a lot of the new stuff and continues to be relevant. So for example, in cloud computing, you have the platform as a service, which is made up of hardware resources and the operating system. Well, the operating system is more than likely going to be a Windows-based or a Linux-based operating system, and you can see here that Linux was developed in the 90s and Windows in the 80s. Going back even further, we see Unix, and Unix is actually the foundation of Linux and Mac OS X. So without getting into too much detail, hopefully this gives you a high-level perspective of the evolution of some major events or major operating systems that have been developed throughout the decades, and to understand that many of the things that were developed even as early as the 1970s have then become the foundation of some of the operating systems even today. So going forward, more than likely these technologies and the information that you'll learn here about operating systems will be relevant in the next decade or two to come. Now let's talk about some operating systems. In the 1980s, Microsoft had an operating system called DOS, and that was a command line interface operating system, which meant you had to do everything by typing in commands. Now, also during the 80s, they evolved that into a graphical user interface operating system called Windows. And so it would seem that at that time, the way things were going was towards a graphical interfaces. But as time has proven, that both approaches are very useful, and we saw that in the 2000s when Microsoft made available Microsoft PowerShell. Now, PowerShell is not an operating system, but it is a utility within Windows that provides a lot of functionality, and it's done through the command line. So the key point here is that one approach does not make the other obsolete. In fact, both approaches are very useful depending on what tasks you're trying to accomplish. The next operating system we want to talk about is Linux. Now, Linux is an operating system that was developed in the 1990s, but in order to understand how that evolved, we really need to go back a couple more decades to the 1970s and look at Unix. Unix itself developed into several different versions or distributions, and some of those included Unix System 5, Unix Berkeley Software Distribution or BSD, and others such as HPUX, IBM AIX, and Solaris. So as Unix evolved, it had a few different branches. Now when Linux came into being, that was developed as open source, and since then Linux has blown up into many distributions. But to keep it simple, I'm just going to talk about a few of the main branches, and that would include the Red Hat based distributions, the Debian-based distributions, and the Slackware-based distributions. In this course, we are using CentOS 7, which is part of that Red Hat family, and Ubuntu, which is part of the Debian-based. So by the time you get done with this course, you'll have a pretty good understanding of Linux, and you'll have the ability to go from several different systems and be able to be proficient in using them, because you'll understand some of the differences between, say, a Red Hat distribution and a Debian. You'll understand where there's similarities and where there's differences. The next operating system I'd like to briefly mention, because it's not going to be a big part of this course, is Apple's Mac OS X. But the reason I want to mention it here is just so that you can see that Mac OS X was actually derived from Unix, the BSD distribution of Unix. And so if you open up a terminal on your MacBook or your Apple computer, you can actually run some Unix commands there at the terminal. So that's an interesting point there. Also, a couple other points. Don't get Mac, referring to the Mac OS, confused with Mac as in media access control, where we're talking about the network interface card, or mandatory access control in an information security context. And finally, don't get Apple's iOS operating system confused with Cisco's iOS. We're going to talk about iOS and Juniper next, so I guess we could talk about that now. But network devices also have operating systems, and that's going to be outside of the scope of this course as well. But Cisco and Juniper are two operating systems that are commonly used on network devices. And again, those won't be the focus of this course. Although there are many similarities between Linux distributions, there are also some key differences that we need to be aware of, and we're going to talk about three of those things right now. So keep in mind, Linux is open source software, which means that anyone can take that software, modify it, and make it their own, and that is indeed what has happened. And if you look at the Wikipedia page for Linux distributions, they've done a great job of showing how the original Linux distribution has branched out into many, probably hundreds of different distributions. And so three of those main branches include Red Hat, Debian, Slackware, and others. But the fact that different people or organizations have created each of those branches would indicate that inherently there's going to be some differences. And so we'll see that in the next section, especially as it relates to installing software. You'll see that commands that work in Red Hat don't work in Debian-based operating systems, and vice versa. The second and third bullets there for the initialization and network suite, these are more based on time. And so as time goes on and new versions get introduced, new tools or commands get introduced, and old ones get deprecated. And within Red Hat, that's even true. So commands that worked in Red Hat 5 or 6 may not work in Red Hat 7. And going forward, some of those older commands will eventually be deprecated and not even available. So that's just something to keep in mind. And that's true of any operating system. Just using Red Hat as an example there. And again, with the network suite, there's tools that have been around for a long time, and as time goes on, newer tools and commands get introduced and the older ones get deprecated. And so you'll see differences not only between distributions, but even within distributions. And we're going to talk a little bit more in detail about each of those items here next. One of the places you'll see a difference between Linux distributions is in the software installation and update commands. For example, in Debian-based operating systems such as Ubuntu, the apt-get command is used, whereas in Red Hat-based distributions such as CentOS, the yum or rpm commands are used. Now at this point, you don't really need to understand these commands or how to use them. The main point here is to highlight differences between distributions. And so again, this is a side-by-side comparison of the commands that would be used in a Debian-based operating system versus a Red Hat-based operating system. Now this is where things can get a little bit tricky, because not only do you need to account for the distribution you're using, but also the version within that distribution. System 5 was used for a long time as the initialization process, and more recently System D has been introduced. So for example, if you were using Red Hat version 6, you would use the service command. If you upgraded to System Red Hat 7, you would use the system control command. Now to understand which initialization process you're using, the easiest way is just to run a command ps-ef, pipe that to more, and look at the PID or the process ID 1, and if it's set to init, then you're using System 5. If it's set to System D, then you're using System D. Again, these commands will be discussed in more detail. The main point here is to understand that there are differences between Linux distributions and even the versions within distributions, and it's important to know where you're at so you use the right command. For this course, the last place you'll need to be aware of differences are in the networking suites. So for a long time, the NetTools commands were used, and over time, IP Route 2 and Network Manager suites were introduced. Now these suites contain several commands that can be used for things such as looking up your IP address or even configuring things that deal with the network. Let's move down here and take a closer look at some of the commands that might be available. So if your operating system, such as Ubuntu, is using System 5 as the initialization process, you may have all these suites available to you, nmcli, IP, and ifconfig. However, if you're using System D, like CentOS 7, then the NetTools may have been phased out, so you may only have the nmcli command or the IP command. The point right now is just to highlight that there are differences between Linux distributions and their versions,